now that you have an idea of what slope fields are, hopefully, there are basically 3 goals that we're going to be looking at with slope fields. In this video, we'll concentrate on that first goal. At the end of this lesson, you'll be able to draw a slope field to represent a differential equation. So we're just going to dig right into a couple of questions and see how we do. Right, this time we'd actually like to draw the slope field. On the previous video, the slope field was given for us. We just kind of looked at it, but this time we actually get to draw it. All right, so we know that dy dx is equal to x plus 2. So we know that the slopes are going to all equal x plus 2. So it's going to depend on the x value. So I'm going to, first of all, let's go to x equals 0, maybe start in the middle and kind of go in either direction. When x equals 0, if I plug 0 in, you'll notice that I get a slope of 2. So whenever x equals 0, all of my lines there need to have a slope of 2, which is pretty steep. So I'm going to try to make them all the same steepness and all be about 2. Okay, now let's move over. This time when x equals 1, if I plug 1 in, all of my lines will have slopes of 3. So we just need to make sure we get steeper than the ones I drew before. And then the next one, x equals 2. If I plug 2 in for the x, I'll get 4. So my slopes all have to be 4, which I just know is steeper than 3. And then when x equals 3, I'll get slopes of 5, which have to be even steeper than the ones before. So you're just going to try to make them steeper. Okay, then moving over to x equals negative 1. If I plug negative 1 in there, I'll get 1. So all my slopes have to have slopes of, all my lines have to have slopes. I should make them not quite as steep as that. They need to be less steep than the ones before it. Okay, then when x equals negative 2, if I plug negative 2 in, I will get 0. So I know at x equals negative 2, all of my lines are going to have a slope of 0. And then when x equals negative 3, my slopes will be negative 1. So they should match the ones at negative 1. They should just be going in the opposite direction. So all of those have slopes of negative 1, and that's what the slope field looks like. And hopefully you can kind of tell by looking at it that their solution is going to again be a parabola. All right, this next one is draw a slope field for each of the following differential equations. So same thing again. This time our slopes will equal x over y. And this one's going to be a little bit more difficult because we have an x and a y involved, so we're going to have to go more on a point-by-point basis. The first thing that I'm going to do, though, is I know that y could never be 0 because the slope would be undefined. So whenever y equals 0, which would be all these points down here, my slope's going to be undefined. So I'm just going to circle them to remind myself that I'm not going to draw anything there because the slopes are undefined there. Okay, the next thing that I'm going to look at is my numerator. I know my slopes will equal 0 when x equals 0. So whenever x equals 0, which would be right along this line right here, I know my slopes are going to be 0. So I can draw slope lines that have slopes of 0. And again, I'm not doing it right here because that would be undefined. Now, we're just going to kind of go on a point-by-point basis and use patterns if we can. I'm going to next look at maybe where would the slopes equal 1, and I know that that would be like at 1, 1, 2, 2, 3, 3. So at 1, 1, my slope will be 1. At 2, 2, my slope will be 1. At negative 1, negative 1, my slope will be 1. At negative 2, negative 2, my slope will be 1. So hopefully those are kind of all supposed to be in the same direction there. Okay, now kind of continuing with the patterns, I might look at, okay, where would my slopes be negative 1? And that would be when the x's and the y's are the same but opposite. So at 1, negative 1, my slopes will equal negative 1. At 2, negative 2, my slopes will equal negative 1. At negative 1, 1, my slopes will equal negative 1. At negative 2, 2, my slopes will equal negative 1. So I think I've kind of come up with all my patterns. Now from here, now I'm just going to take all the points that are left and actually plug them in. So this next point is 1, 2. So if I plug 1 and 2 in, I'm going to get 1/2, which you'll notice is less steep than the ones that I drew at 1. And then let's go over here, negative 1, 2. That would give me negative 1/2. And then let's go down here, 1, negative 2 would give me a slope of negative 1/2. And then negative 1, negative 2 would give me a slope of 1/2. So hopefully you're kind of seeing some patterns going on here. The next one we're going to have negative 2, 1. That would give me a slope of negative 2. So steeper than those ones. And then negative 2, negative 1 would give me a slope of 2. We'll come over here. 2, 1 would give me a slope of 2. 2, negative 1 gives me a slope of negative 2. All right, over here, 3, 1 would give me a slope of 3. Whoops, should be steeper than the one of 2. 3, negative 1 gives me a slope of negative 3, so it's got to be steeper than that one. Negative 3, 1 gives me a slope of negative 3. 1 gives me a slope of negative 3. Whoops. And then negative 3, negative 1 gives me a slope of 3. So I'm trying to get steeper each time, and then we've got one more dot left here. 3, 2 would give me a slope of 1.5, so it's going to be a little bit steeper than this one. And then negative 3, 2 would give me the same thing but negative. And then negative 3, 2 would give me negative 1.5. This gets a little tricky, just a little bit steeper than that one. Oops, it's not much. And then 3, negative 2 gives me negative 1.5. So let's see if I can get the same as that, just a little bit steeper. Okay, so hopefully you can kind of get an idea of what's going on. I almost see maybe like some parabolas going there and parabolas going this way, so we kind of got lots of different things going on depending on my C value. Probably would depend on my solution curve for this one, but hopefully you get an idea. It's kind of showing us what the answer to this equation would look like. So hopefully now you're familiar with drawing a slope field if you're given the differential equation.